And there's some of them out. These little bluebonnets that you see are only about this tall, but this is the Pt2 chihuahuensis, and this particular bluebonnet is ordinarily about this high. So these are, all these plants that you see out here are, what botanists would say, are depopera. They're on the edge. In fact, you can see a lot of the edge. It was much cooler and much wetter here in the past, and you can see the results of a severe drought we had 2 years ago, and you can actually see which plants are making it and which ones are not. We lost about a third to a half of our cyclones that year. Some cacti everywhere died. They are not surprisingly all that able to resist that, and a lot of the lilies, like the lechuguillas and things, died out quite a bit. And you will see them, the lechuguillas, you know, cacti just shrink up and go away. With the lechuguillas, you'll see their dead lechuguillas all over the park. This happened as a result of the very dry summer and the very bitter freezes we had after that. Very, very bitter winter out here.
That was 2 years ago?
So 2 years ago, yeah. So the plants themselves generally deal with situation by just 3 or 4 kind of, I would say, grand schemes of things. Succulents is one of them, so the cacti are succulents. There's an echeveria that's a succulent. These are plants that have very shallow root systems that spread out for a very long distance. And they catch every micron of water that comes down and they store it in their bodies. And then they use it as they need it. Cacti are particularly unique. I mean, there are about 3 different primary photosynthetic pathways, and cacti are unique in that they use a photosynthesis channel called cresolution acid.
Crescelic acid? Crescelic acid?
No. Rabbits. Well, anyway, they make this acid, and what they do is during the day they keep all their pores closed. Cresolution acid. They keep their pores closed so there's no respiration going on because it's hot. And they create the photosynthetic pathway. Instead of creating carbohydrates, creates this particular acid which they store. And then in the evening, when the sun goes down, they open their pores and start bringing in the carbon dioxide, and they convert the acid into carbohydrates that they can then live on. And that is very unusual in the plant kingdom. They're the only ones that do that. We have a lot of, you'll see a lot of them. You'll see a lot of grasses out here, which out here are nearly all what they call C4. It's a smaller, it's a variant of normal photosynthesis. It is much more tolerant of high intensity sunshine than a lot of others. Many of plants like house plants, you take them out and they burn or one thing or another. I mean, it's just too intense for them and they can damage them. But the grasses and things do very well, which is why they're so well adapted out here. And of course, most of the plants have very specialized root systems, even for families that are the same as plants that you would see in other parts of the world. Nearly all of them have extremely extensive plant system and root systems. Most of them, at least 2/3 of the plant is underground. And in fact, that is true of nearly all life out here. Most life you will never see. It's underground. A lot of the plants like the